Hey Pre-Calc, Mr. Rashid here, and today we are looking at special right triangles and how to find missing side lengths using their special properties. Now, most of what you'll see in this section could potentially be solved using either the Pythagorean theorem, which is a squared plus b squared equals c squared, or you could use sine, cosine, or tangent to also solve these side lengths. Now, the reason we're learning this is that the ACT and the SAT, they love to throw these types of questions in there. And if you work out the amount of time it takes you have per question on those, it might be a minute or a minute and 20 seconds or so, and many of the problems, it's much faster to solve them using what we're about to learn here rather than pulling out the Pythagorean theorem or the sine and the cosine tangent to solve the problem. So that's why we're working on these sort of shortcut methods. If you see that there's these special triangles in there, then you can invoke this. Okay, so the first of these special triangles is the 45, 45, 90. So you've got 45, 45, 90, and that means there's a 90-degree triangle, meaning it's a right angle triangle, and it's also an isosceles triangle where two of the angles are the same there, 45 and 45, and then also, well, the two angles being the same implies that two of the sides have the two opposite sides have the same side length. So for this type of triangle then, the special rule or scenario is that if you have two congruent legs like this with the same lengths, and it's a 90-degree triangle, then the hypotenuse of this kind of triangle has a length of the leg times the square root of 2. So the hypotenuse is the leg times square root of 2. And then the two legs are the same. Now if you had the hypotenuse and you wanted to go backwards and get the leg, then you would divide by the square root of 2. So you divide the hypotenuse by square root of 2 to get the leg. So that's the first special triangle. The second special triangle is a 30, 60, 90. So again, we have a right angle triangle, but one of the angles that's not the 90 is 30 degrees, and the other angle is 60 degrees. So in this kind of special triangle then, you'll notice that, like in all triangles, the side opposite the smallest angle is the side with the shortest length. And in this case, we can call that the short leg, because of the two legs, that's going to be shorter. It's opposite the 30 degrees. Then the long leg is going to be opposite the 60 degrees. And the long leg is the square root of 3 times the short leg. So square root of 3 times the short leg will give you the longer leg of this type of right triangle. And then finally, the hypotenuse is always going to be opposite your 90, and the hypotenuse is 2 times the shorter leg then. So that's the other special triangle. So let's take a look at some problems and how we can go about solving those. So these are all 45, 45, 90 triangles. You can tell because we have a right triangle, first of all. We have right triangles. Then one of the angles is 45, and using the sum of triangles is 180. The other angle has to be 45 here. So that's 45 degrees. And in this case also the same thing. So the other angle here is 45 degrees. Now, what do we know about 45, 45, 90s? We know that the hypotenuse is the leg times the square root of 2. And we also know that both legs are the same. So the sides opposite the legs here are these ones. So B is 2 times the square root of 2. It's going to be the same side length as the other leg because it's a 45, 45, 90. And then to find the hypotenuse, all I need to do is multiply the leg by the square root of 2. So if I do all of this math here, square root of 2 times the square root of 2 is just 2. 2 times 2, and that is 4. So A is equal to 4, or the hypotenuse in that case is equal to 4. Okay, now here we have an example where we have now the side that's opposite the 90. So that is our hypotenuse. And so since we have our hypotenuse, then we'll have to work backwards to find what our leg is. So because we multiplied the leg to get this by square root of 2 to get the hypotenuse, we divide by the square root of 2 to get the leg. So any of these here, x is equal to 2 square root of 6, and I'm going to divide by the square root of 2 this time. Now, many students simplifying would multiply numerator and denominator by the square root of 2, but you can also use the product property of square roots and say 2 times the square root of 2 times the square root of 3 is the same as writing the square root of 6, and that's all divided by the square root of 2. If I divide and cancel out the square root of 2, I'm just left with 2 square root of 3. So that's one of the legs. And then we also know this is an isosceles triangle. The sides opposite the 45 are congruent to each other. So y is also 2 times the square root of 3. Okay, last two examples here. So this time we're dealing with 30, 60, 90 triangles. And I can tell because this is a 90 here, and if I have 60 degrees here, then this other angle is going to be 30 degrees using sum of angles in a triangle. So now that I know that it's a 30, 60, 90, then I have these types of rules. So I know that the short leg, this y here, that's going to be the shortest leg because it's opposite the 30 degrees. And in this case, this is 30 degrees. And I know this, the y again there, that is going to be the shortest leg in that diagram. So going back to the first diagram, I usually just start with the number. There's two ways I can show you here. So the first way is to say, well, this is the long leg here. So, or I'm sorry, this is the hypotenuse. So this is the hypotenuse. It's opposite the 90 degrees. So since I know the hypotenuse is twice the short leg, then I can divide by 2 and get that the short leg is 8. And I know that the long leg, meaning the side opposite the 60 here, is the long leg is square root of 3 times the short leg, and say that is 8 square root of 3. So that's one way to do this type of problem. The other way I can show you is you can recognize that this is a 30, 60, 90 and kind of ignore the numbers and the letters around it and write your own relationship around this triangle. So I know this is the short leg, so I can ignore this and just keep the number there. So I write x as my short leg. I know my hypotenuse is 2x, and I know my long leg is square root of 3 times x. Or let's write it this way. x times the square root of 3. Then what I do is I search for where I have numbers for the side length. So I've got a number right here. So I set that equal to whatever I wrote. So 16 equals 2x. I would solve for x there and get x equals 8. And that means I can put x over there and say x is equal to 8 and put x over here and say 8 the square root of 3. So that's the second way that you can do these types of problems. So let's go back. I'm going to use the first method maybe on this one. So the short leg is y, okay, and the long leg here, so that's the side that's opposite to 60, is square root of 3 times the short leg. So I can see if I divide by square root of 3, I'm going to get the short leg. So this is 5, and I know that the hypotenuse is double that, so that is 10. And that's it. I'm done with that. So that's it for this video, and try out the homework problems we have here. Bye.